Now, in this topic, we are going to discuss one more very interesting concept related to the aromatic electrophilic substitution, ओरिएंटेशन अँड रिॲक्टिव्हिटी. या टॉपिक मध्ये हा एक खूप महत्वाचा असा कन्सेप्ट आपण बघणार आहोत, ओरिएंटेशन अँड रिॲक्टिव्हिटी रिगार्डिंग aromatic electrophilic substitution. Suppose this is our aromatic ring. Suppose that benzene ring having any substituent, that benzene is already substituted. म्हणजे ऑलरेडी जर बेंझिन सबस्टिट्यूटेड असेल, फॉर एक्झाम्पल फिनॉल, in phenol there is one OH group, then aniline there is one NH2 group. Suppose nitrobenzene there is one nitro group. In that cases the question arises at what position electrophile can attack. म्हणून माझं पहिलं स्टेटमेंट काय असेल, when substituted aromatic compound undergo electrophilic substitution which having, if there is already one group present on the aromatic ring, then it influences the rate of reaction. That group which is already present on the aromatic ring, it influences the rate of reaction. Means it affects on the reactivity of that compound towards electrophilic substitution. It may be increase the reactivity or it may be decrease the reactivity than benzene itself. मी काय म्हणतो व्यवस्थित लक्ष द्या. The group which is present, the group which is already present on that benzene ring, it influence the electrophilic substitution in two ways. तो जो ग्रुप त्या aromatic ring वरती आहे, it can influence the electrophilic substitution in two ways. दोन प्रकारे तो त्या ठिकाणी इन्फ्लुएन्स करतं electrophilic substitution. First influence काय आहे? It influence the rate of reaction. It influence the reactivity of that particular aromatic compound. Means it may be decrease the reactivity or it may be increase the reactivity than benzene itself. Okay, this is the first part. Then second part, there is one more part. At what position electrophile should be attacked? Means that group which is already present on the aromatic ring, it can be affect on the, it can be influenced on the, at what position electrophile should be attacked. Means different types of the group can influence orientation of the aromatic compound towards electrophilic substitution. In some cases, the electrophile can attack on the ortho position, para position, or in some cases it may be attack at the meta position. And this is called orientation. म्हणजे कोणत्या पोझिशनला, at what position that electrophile should attack. That is called orientation. That theory is the orientation. Now, here we are going to discuss in detail about that also. These are the two ortho position. These are the two ortho position. Okay. Then there are two meta position also, and there is one para position also. Now, what is the question? At what position electrophile should be attacked? And this is depends upon the nature of this group, nature of that shade which is already present on the aromatic ring. On that basis, how it can be causes orientation, how it can be causes reactivity in the aromatic ring towards electrophilic substitution. On that basis, substituents are classified into three categories. There are three main types. There are three main categories regarding that. One is the ortho and para directing group with activation. We will see one by one. There are three categories. First category is the ortho and para directing groups with activation. Now let us see some examples. Suppose this is our aromatic ring. It is already substituted by Z, and there are positions ortho, meta, and this is the para position. Okay. Consider the examples of some group. Suppose instead of that Z, हा जो Z आहे त्या ठिकाणी कोणता ग्रुप आहे? Suppose there is the NH2 amino group, then secondary amino, tertiary amino, amide group, then oxygen having the negative charge, there is hydroxy group, alkoxy group, etc. Here also thioalcohol, then SR, alkyl groups also. That groups are ortho and para directing group. These are the ortho and para directing group. Okay, means what? If that groups are present on the aromatic ring, if that groups are already present on the benzene ring, then electrophile should be attacked at ortho and para position. Then what's about the reactivity? Benzene ring containing this category, group of this category are more reactive towards electrophilic substitution than benzene itself. This is called activation. म्हणून मी हेडिंग मध्ये काय दिलेलं आहे? Ortho and para directing group. This is the first category of that substituent. This is the first category, ortho and para directing group with activation. And these are the examples of this category. Suppose that atoms or group are present, already present. What is the word? Already present. Suppose these atoms or group are already present on the aromatic ring, then electrophile attacks at the ortho and para position. This is the first factor. Second, if that groups are present on the benzene ring, then it's a reactivity. It's a reactivity towards electrophilic substitution increases than the benzene itself. म्हणजे मूळ बेंझिनची जी रिएक्टिव्हिटी आहे त्यापेक्षा that compound is more reactive towards electrophilic substitution. Okay, and these groups are called ortho and para directing groups with activation. याच्याबद्दल आपण डिटेल मध्ये डिस्कस करणार आहोत. Why they are ortho and para directing, how they causes ortho and para orientation, and why the compounds are more reactive due to presence of such group. हे आपण डिटेल मध्ये नंतर बघणार आहोत. पहिल्यांदा मी फक्त एक्सप्लेन करतो these three categories of different types of the groups. Okay, this is the first category. Now let us see second. Second category is the meta directing groups. They are meta directing groups with deactivation. Suppose this is our substituted benzene substituted aromatic compound, that there is a shade which is already present on that aromatic ring. Okay, now let us see examples of some groups. Okay, these are the examples, very well known examples. One is the nitro group, then NR3, here nitrogen having positive charge, then cyano group, CHO, COR, then COOH, then COOR. COOH is the carboxylic group, then this is the ester group, then CONH2, then sulfonic group, CCl3, CF3. Actually, that atoms are group. They causes electron withdrawing mesomeric effect. Now, what is the role of that particular groups? Suppose benzene having that group, already it having that group, then electrophile attacks at meta position. Means orientation is the meta. If benzene already having that group, then that electrophile attack at the meta position and it undergo electrophilic substitution at meta position. This is the orientation. Now what's about the reactivity? Actually, these groups are electron withdrawing, and therefore if benzene having groups of this category, then it is less reactive towards electrophilic substitution than the benzene itself. This is called deactivation. Means due to presence of that atoms or group, reactivity of aromatic compound decreases. Due to presence of that atoms or group, reactivity decreases, and therefore they are called as the deactivating group. म्हणून त्यांना आपण deactivating groups असं म्हणतो. They are meta directing. याबद्दल आपण डिटेल मध्ये स्टडी करणार आहोत. Why they causes attack at the meta position, means why the electrophile attack at the meta position, why there is a decrease in the reactivity. हे थोडंसं आपण डिटेल मध्ये पाहणार आहोत at the end. Okay, let us see third category. यामध्ये तिसरी category, it is different. Actually, it is ortho and para directing, but with deactivation. Means they causes attack of electrophile at ortho and para position, but they decreases the reactivity of that particular aromatic compound. Now consider the examples of that category. Halogens are examples of this category. या कॅटेगरीचे एक्झाम्पल आहे हॅलोजन, फ्लोरीन, क्लोरीन, ब्रोमीन, आयोडीन. If aromatic ring having halogen already, जर त्या aromatic ring मध्ये ऑलरेडी हॅलोजन असेल, म्हणजे इथं जो आपण छेड दाखवलेला आहे, instead of that shade, suppose that ring having halogen, then the electrophile attack at ortho and para position. Electrophile attack at ortho and para position means halogens are ortho and para directing, no doubt about that. But what's about the reactivity? Here benzene, if having halogen, then it is less reactive towards electrophilic substitution. It is less reactive towards electrophilic substitution than the original benzene itself. Means we can say that these are the deactivating groups. This is called deactivation. Okay, means that halogens, they causes electrophilic substitution at ortho and para position. but they decreases the reactivity of benzene ring, they decreases the reactivity of that aromatic ring than the benzene itself. Therefore, they are deactivating groups. Okay, this is the third category of the substituents which are present on the aromatic ring. Okay, we have just overlooked about the three categories. यामध्ये फर्स्ट कॅटेगरी कोणती आहे? ऑर्थो अँड पॅराडायरेक्टिंग ग्रुप विथ ऍक्टिव्हेशन. Then second, meta-directing group with deactivation. And third, ortho and para-directing groups with deactivation. Okay, these are the three categories. मग फर्स्ट कॅटेगरी मध्ये कोणते atoms किंवा ग्रुप आहे? इन फर्स्ट कॅटेगरी NH2, NHR, NR2. That means those atoms or group which having lone pair of electron, those having lone pair of electron, those having plus M effect, those having electron donating mesomeric effect, right? Then what's about the second? The examples of second category: nitro group, cyano, aldehyde, carboxylic group. They are having electron withdrawing mesomeric effect. That is minus M effect. Okay, this is again meta-directing with deactivation. The third category, they're having halogens. They're having ortho and para-direct. They are ortho and para-directing, but there is a deactivation. That decreases the reactivity of particular aromatic compound. Okay, this is just about the these three categories which influence the orientation and reactivity of aromatic compound towards electrophilic substitution.